Hello everyone, today I will do a demo presentation. So my name is Jiasheng Liu, a second year student of ECE department. So my project is implementation and compression of face recognition based on the three traditional feature extraction algorithm. So first of all, let me introduce some background and the significance of the selected topic. About the face recognition. Human can recognize its face without any effort. Um, Facial recognition is a challenging pattern recognition problem in computing. So the facing recognition system attempts to identify a human face, which is three-dimensional and changes in appearance with a lightening and facial expression based on its two-dimensional image. So to accomplish this computational task, facial recognition system perform four steps. The first step is the face detection. It's used to segment the face from the image background. In the second step, the segment face image is elegant to account for face pose, image size, and photographic properties such as illumination and grayscale. The purpose of the algorithm process is to enable the accurate locationization of facial feature in the third step, the facial feature extraction. So the features such as eyes, nose, and the mouth are pinpoints and measured in the image of the represent the face. Uh, so the established feature vector of the face is then in the fourth step matched against a database of face. So when you do the face recognition, we're going to meet a lot of problems. The most famous for problems is here. Look at the picture right here. So the first one is like the man is in the different angle. Um, this is the side face. Here is the front face, and also the different intensity or the illumination. Like this one is grayscale, and this one is like a RGB image. And here, like something is blocking his face, like the sunglasses or his face, or some microphone here. And we need to know that they are the same people. Also, like the different age of the people of the same people. Like he's getting old and getting fat compared with the 10 years before. So, in this part, I will introduce a little bit of the traditional algorithm and the development of face recognition. So the face recognition technology has changed significantly in those years. Traditional methods rely on the handmade model features, such as the edge texture description, and the method that combine machine learning technology, such as a principal company analyze, linear discriminal analyze. We're gonna use those in this project, and SVM. Uh, so because of the function of this project, there's a difficulty uh, that must be overcome, like the adapt to different variability in unconstrained environment, like those different parts. So this let the researchers focus on result those things very typically. So but in the recent years, the traditional face recognition method has been replaced by deep learning, rely on the convolutional neural network. So, but in this project, we're gonna focus on the feature extraction. So we need to use the traditional algorithm for the face recognition. So in the next part, I'm gonna introduce the three algorithm I used in this project. The first algorithm is the PCA. Actually, PCA is a data dimensional reduced algorithm, which is widely used in face recognition. As the name suggested, the PCA algorithm is to find the most important aspect of the data and replace the original data with the most important aspect of the data. So in the space, let's look at this picture. Like those points are in this two-dimensional uh, space. So what PCA can do is like PCA can be understood as projecting the original data into a new coordinate system, like this one looks like. The first principal component is the first coordinate axis here, and the second component is the second coordinate axis, which represents the change interval of the second new variable obtained by the curtain transformation of multiple variables in the original data. So also in implying this part, in the code part, I remapped the mean matrix and the feature matrix to the gray level interval of the 0 to 255 and got those two so-called average phases and eigenphases, which will be used in later. And one example is shows here. They are the same picture original data, and after I use this one, I gonna get average phase and eigenphase is here. So after I use the PCA to this one, and I can compare. I know the feature and I got the data, so I can compare to each other. So I actually use the wiki uh, data set and I change it into the full data set. The difficulty of the data set, this one is easy, much more harder, much harder, and it's the hardest one. Like it focusing on more about this can and this can. So we can say like the easiest one is definitely accuracy is the all accurate, but which express me is like the hardest one is also the best one. Here is good, but this one is pretty easy, but it didn't get a good performance. I don't know why. I can continue work on this. And here are the running time of this code. Okay, so the next algorithm I'm going to introduce is LDA. So the goal of the LDA is very similar to PCA. So the goal of the LDA is the projection the points obtained by different classification should be separated as much as possible. The points obtained after the same classification should be aggregated as much as possible. So as we can see in the picture here, so we got the blue point and the red point. We need to reduce the dimension, so we can change the two dimension here into the one dimension. But we get here this is the number of the uh, blue points and the number of the red points. So the best result is like this. So there's nothing. There's actually all the blue point is over here. The red is over here, and but this one is not good enough. It has some place that is together. So this one is what we want to get. So after we doing the LDA, we can get the average phase here, like here and here. And also here's the result of the two data set is pretty bad actually of the 96. And here is the running time. So for the next part is the LBP algebra. So we can see here it's like it have three neighborhoods like here, and we compare the pixel here and to the central point. If it's smaller, it's 0, bigger is 1, so we can get 0, 0, 1, 1, 1, 0, 0, and I got those image. And after I do LPA with the original data, it's gonna be like this. And if you want to do the uniform LBP, you need to check the boundary here and then do more stuff or work, and you can get this one. And we are using this one in this project. And here are the final results of the full data set, and very good in this one and this one as well, and very good this one 95, and also the 95. Maybe this is the reason, or maybe the 95 maybe is the most difficult, but I didn't mean to do that. So the next part, we're gonna do the research results and then analyze it. So first of all, we need to comprehension of the accuracy of the face recognition of the each algorithm. So it's easy to say that LBPH is the best actually, and then is PCA. The worst is LDA. But actually, the accuracy is very similar to each other of about the PCA and LBPH. So, and here is time required to run for the feature extraction. Here is the code that I need to get the feature. So as we can see, as here is the time it need, and here actually is the size of the data set. It's actually the different kind of people. So with the size of the data set become bigger, so the LBPH will using the less time, and PCA will be influenced by the size of the data set. It's gonna be very big after the different kind of people here. So here is the time that the whole system, the face recognition, need to take the time. So we can say like the PCA and LDA don't need too much time, but LBP needs a lot of time. That's because of like after you get the feature of all the people, LBP will look up every picture in the dataset to compare with this picture, so that we can find the most find if this is the people we're gonna to find. So, but after all, but you can reduce this by changing the size of the picture, like changing it to 50, max 50 or 2020. So that's the result of this project, and we can see like the LBPH is definitely the best for the traditional face recognition. So that's all. Thank you for looking.